Hello and welcome to the second video for my current course SDV602. This has been made for Milestone 2, my Milestone 2 project. So in this the primary focus will be on Unity, the facet of Unity that we've been covering at the moment, SQLite, and also we'll be touching on domain classes and controller classes where they tie into SQLite especially later on. And so without further ado, let's start. So to start off with, I'll look at the history. SQLite was designed in the year 2000 by a man named Richard Hipp. He was originally designing software for a guided missile damage control system. So I'm not sure how he ended up designing a database that's used for mobile devices across the world, but that's where it started out. The purpose for SQLite being developed is to allow a program to operate with the database without the need to install a database management system or needing any database administration. So, as I'll talk about later on, it's lightweight, and this further helps there. Anyway, so SQLite is the perfect database for mobile device applications. This is about it. Because mobile platforms don't have large computing resources available, and this is what most databases are built for. So any normal database like MySQL and SQL Server take a lot of resources, so they're not really feasible to be used on mobile devices. So this is where SQLite comes in. It sacrifices a lot of the functionality of databases like the MySQL and the SQL Server. This is to save on computing resources, which makes it the perfect data storage for mobile devices. So it's also adaptable, so this next bit's going to talk about that. So SQLite is it's basically it's a relational database like SQL Server and MySQL, so it's relational, but unlike them, it's embedded into the end program. So, for instance, if we look at the file system for this, streaming assets, in my case, I've got two databases. Just how I decided to design and work my program, but a lot of programs will just have one. And anyways, each of these files contains a database, which is easily opened by many different programs, and being in one file, it also makes database very portable, mobile, easy to use. And SQLite also has bindings to many programming languages. For instance, I'm using C#. Binding to it, I'm using C#, but it's not just usable in C#. It's also, from my research, is used in quite a few other programming languages. And the fact that it's usable in so many platforms like this, it makes it very adaptable. A lot of software can use it, but it's not restricted, which is really, really good. SQLite is lightweight, as mentioned earlier, so it contains a lot less data types than your standard other SQL database systems. I've noticed that when I was creating mine using the SQLite Manager. It also doesn't allow functionalities like multi-user access, so it's not for instance, suitable for the multiplayer we're looking at doing later on in our game. It's primarily used for local storage. That's where it shines. So I do believe that's the programming language explored. For the most part, it's SQLite, which is what was introduced in this milestone, on top of the original Unity. So here we'll look at, this is where I'll start looking at the domain and control classes as well, and then I'll talk about those, and then we'll look at how they tie in with SQLite. So if I look at my program, the code of it, we can see here I've got my, for instance, player manager, login manager, story managers. The way I've worked it is these three are pretty much these are my models. The way I end up developing my system is almost a model view model over the model view controller I originally was going for. Just how my design ended up working. Where was I going with that? Oops. Yeah, so these are my models, and the model of model view model, or even model view controller, is where the data is accessed. Your model takes your data, is where the data comes from, and is used by your view and manipulated by controllers. So the way my game works, I've got a story manager and a player manager. These two manage all my data. Login does a bit, I guess. Just the login data. But these two primarily. And how it worked is as I said before, I had two databases. So I've got a database per one of these managers. I felt there was a more it just flowed and worked better with my system. So you can see here, this is where I'm creating my database. No, not creating, I'm inserting my data. So it's checking if the story exists. If it doesn't, then it's going to insert it. Inserts my individual dialogues into my dialogue table. This one here is what makes it my first dialogue, and then the rest are just individual dialogues, which I shall call later on. So this file creates my data, creates and inserts it into the database, and then I've created methods down here which allow me to get the data out. And then the same thing with my player manager. I create my new player here, so that's adding my data in my database. Then I can get it out using my login, check my data. But down here, I also allow myself to update my player data. This was a little bit different to the rest. This one I'm using the core SQL language. I'm basically updating my database directly with a script. So basically those are my models which allow me to control my database. So then this data is taken by our controllers. For instance, for these references, where's it going? Scene controller. Oh, yep. So that's what I'm going to look at next. So, for instance, I'm taking that data from the database. My controller is manipulating it and then displaying it in the view. For instance, here it's taking it, checking which scene it is in, and then displaying the correct data accordingly. Updating the data accordingly. In that respect, in that instance, I wrong. Yeah, updating it. Here, yes, I added a continue game function to my game. So here it's taking the data from database, and then it's checking that which scene. It's taking just a specific column, the current scene of the player, using the player's current username of their login, and it's checking for that scene, checking if that scene is equal to the current scene. So it's checking if my current scene is either of these two. If it's not, then it will continue from the last scene recorded in my database. And this allows a player to continue where they left off. And then I added other controllers, which, well, not everything's working yet. Settings and inventory. My inventory is not working yet. I'm doing my scoring a different way, but that will be working for Milestone 3. But I've got the controller there as well. I'm starting to set up the functionality. Same thing, my score controller. I'm controlling my scoring through this controller. It's taking from database, allowing me to take from database, updating it here. I'm able to get it. Where was I? Yeah, getting it here when I load, and then it's displaying it on my interface. Okay, so these are domain. So the manages all my domain classes or my models in many ways, and then I've got my controllers. So that's my domain and how it works. I've got a lot more here, but they're my bigger or primary ones. Okay, I think I've rambled a bit long with that, but okay. So the way SQLite works, so SQLite, as we saw, passes information to the domain class. It does it through reading a single file, as I mentioned earlier. But what we're using is a GitHub open source project, which is provided free. It contains a plugin folder, which contains pre-built libraries, it contains all needed libraries for SQLite to run smoothly. This saves much valuable coding time, of course. They also provide, as well as a plugin, is one file of code which allows the plugin allows us to access use SQLite, allows us to communicate with our SQLite database and manipulate the data within it. I think I sort of did this a bit backwards, but it's right. I think I've covered what I need to here. Just look at my notes just to make sure I covered everything I needed to. Yes, I covered the controller and the domain classes. The model classes are what use SQLite, and they're responsible for managing data, displaying view. Yeah, and as I mentioned earlier, I was developing my game more as a model view controller, but the way I've worked it in the end is I think I've made it more model view model. It's just seemed to fit my game better, or should I say, my game fitted that model type better. Because yeah, okay, so I think it's software platform. I've analysed SQLite, I've analysed the domain and controller classes. Okay, so the last phase of this video, two last phases, is the advantages first and then the disadvantages. So with the advantages, yeah, well, SQLite has actually got a lot of them. It's got better performance, being so small, it's and lightweight, it's faster to read and write from. The database, SQL database file, it's got that single database file, which is faster to read and write from than from a disk, for instance, or even communicate over a server, like most other database systems. It's got better loading speed as a result. It's only has to load the data it needs rather than reading an entire file. So SQLite's really good in that respect. It's portable, with data being stored in a single file. And it can be viewed with a wide variety of third-party tools. I think I mentioned that earlier, for instance, how it's in that database file, the .db file. That file format, there's quite a few third-party tools. I haven't looked into a lot of them, but I've seen a couple, and there seems to be quite a few out there capable of opening this file and reading the data within it, which is really good. The disadvantages of SQLite, there's not many, but a couple of them were briefly touched on earlier. Multi-user systems, it isn't good for multi-users. It's only good for instance, local systems. Also, it locks down the system file to prevent conflicting writes. So it's generally can only do one writing at a time, one thing at a time, which I've noticed in my database. If I open it in another program, it does that, locks the file. And just the fact that it's better for medium to small applications due to its small database size limit. I think someone mentioned it had a 2 gig limit. Other than that, there's not a lot of disadvantages to SQLite. And I think that concludes the video. Sorry it's so long. I've rambled a little bit, but thank you for watching. I hope you enjoy.